So today, yep, we will be looking at the City and Guilds past paper. So that's this one here. The first part is the non-calculator section. So I think we're best off just getting started and seeing how it all goes. Let's have a look at question 1. So I can see here that question 1 says, what is 108 as a fraction of 648? Give your answer in its simplest form. Right, so in the first instance, I'm just going to actually write 108 as a fraction of 648. Okay, so that simply looks like this. Now, this question is really about our ability to halve numbers in order to simplify this number. So I'm going to look at halving these numbers to keep the fraction equivalent and to get this down. So I know that 108, if I'm going to half 108, I can think about it as 108. So half of 100 I know is 50. Half of 8 is 4. So 108 divided by 2 will be 54. 648, I'm going to think about it as 648. 600 divided by 2 is 300. 40 divided by 2 is 20. 8 divided by 2 is 4. So if I'm going to divide 648 by 2, that's going to give me 324. Okay. I can see that both of these are even numbers, so I can simplify this further. I can see that 54 can still be split up into 50 and 4. So half of 50 is 25. Half of 4 is 2. So if I add those together, that makes 27. Half of 300 is 150. Half of 220 is 10. Half of 4 is 2. So if I add these together, that makes 162. Okay, right. Unfortunately, this can simplify some more because I know that a good test here, I know that both of these numbers aren't even anymore, so I know that they can't both be halved, but I do know that 27 can be divided by 3, and I do know that 162 can be divided by 3, because if you do 1, add 6, add 2, this equals 9, and any number where the digits of that number add up to a multiple of 3 can be divided by 3. So 162 will be divisible by 3. So I'm going to quickly do this with using the bus stop method. Okay, so 3's into 1 don't go. 3's into 6, well, I'll have to carry that one. 3's into 16, well, 3 times 5 is 15. So that goes in 5 times, and then 16 take away 15 equals a remainder of 1. So now we're looking at 3's into 12. 3's into 12 is 3 times 4 is 12. So they go 4 times here. So what I get, this is equal to 9 over 54. Now, we've got to simplify again. Now, I actually do know that both 9 and 54 are in the 9 times table. Okay, so I can divide both of these by 9. So I know that 9 times 6 equals 54. So if I divide both of these by 9, what I get is I'm going to get that this becomes 1 over 6. So to get 108 as a fraction of 648 in its simplest form, the answer will be 1 over 6. And just to recap that, we halved again, we divided by 3, and then we divided by 9 because I recognised that both those numbers were divisible by 9. Okay, so that is 1 mark. Right, let's have a look at question 2. So here we go. We've got which of the following list is in decreasing order. So that means going from largest to smallest. Okay, right. So from the bat, I can see that B does not go from largest to smallest because I know that 0.05 is less than 0.15. Okay, we've been looking at place value this week, if a number is here, it is worth more than the number that's next to it. So I'm just going to scribble this one out. It's not that one. Okay, next, I can see here as well, we've got 0.05 before the 0.15. So it's not going to be this one. Here, I can see that the 0.15 and the 0.05 are in the correct order. So I'm going to have to evaluate the fractions. So if I've got 1 over 5, okay, I know that 1 over 5 is equal to 10 over 50, okay? So that's because equivalent fractions, we've times both of these by 10. So I know that 1 over 5 is 10 over 50. The other fraction we have is 17 over 50. Okay, now 17 over 50 is bigger than 10 over 50. So that means that C can be ruled out because 17 over 50 would have to come before 1 over 5. So we're going to rule that one out. And then, therefore, by process of elimination, I know that the list that is written in correct decreasing order will be D. Okay, right, let's look at the next page. So here we go, we've got question 3. Okay, and it shows us that we've got a diagram of a regular polygon. Regular polygon means that all the sides and angles are the same. So regular means everything the same. Okay, so if we've got a regular polygon, everything's the same. So that means if we've divided it with all of these lines, all of these angles are going to be the same. So what this question is really, it's about angles around a point. So we need to know that angles around a point equal 360 degrees. Okay, so all of these angles will add up to 360 degrees. We've got 1, 2, 3, 4, 5, 6, 7, 8 angles there. So what we're going to have to do is we're going to have to divide that 360 degrees by 8. So we're looking at 360 divided by 8. I'm going to just simplify this by going divide by 2. So that's going to be 180 over 4, which will be 90 over 2, which I know 90 divided by 2, half of 90 is 45 degrees. Okay, right, question 4. So question 4 says, work out the value of y if 4y equals 144. Okay, so if I've got here 4y equals 144, well, I can do 2y equals 77 because I've just halved both sides. This is kind of like direct proportion here. And so if 2y equals 77, y is going to equal 77 divided by 2. So let's split this up to divide this by 2. 77 is like 60 plus 10 plus 7, well, plus 6. 6 plus 1. I know that this is a complicated way of doing it, but I know how to halve all of these numbers. So half of 60 is 30. Half of 10 is 5. Half of 6 is 3. And half of 1 is 0.5. So this will be 30, 35, 38, 38.5. So y equals 38.5. Okay, right. I hope this is all okay. Question 5. So here we have 3 squared divided by 3 take away 28, and we want to know what that is. So we need to remember that 3 squared, this little squared sign, means you multiply the number by itself. So 3 squared equals 3 times 3. So here we go, what we're going to get is that means that this is going to come 3 times 3 all over 3 take away 28. So what we have is, if you ever see like something like this here, like this 3 times 3 over 3, if a number appears in this situation when you've broken it down on the top and the bottom of the fraction, you can cancel them out because it is just like dividing the top and the bottom by the same number. So I'm going to divide this fraction, top and bottom, by 3. So I can see that this fraction just becomes 3 over 1. So 3 over 1 is equal to 3. So this question becomes 3 minus 28. Well, 3 minus 28 is going to be negative 25 minus 25. Here we go. I should put that on the line. Minus 25, okay? You can kind of think about it as 28 take away 3, okay? Because that tells you what's left, 25. But then it's got to be negative because we've taken away the larger number, okay? So the answer to this one is negative 25. Right, let's go on to question 6. Here we go, we've got question 6 here, and it says the radius of the top of this circle, of this cylinder, is 7 centimetres. Okay, use pi equals 22 over 7. What is the volume of the cylinder? Okay, so the volume of a cylinder equals the area of circle times the height. Okay, so we first of all need to work out the area of this circle. So have a think, can you remember the formula for the volume of area of a circle? Hopefully you can, because it is equal to area of circle equals pi times the radius squared. Okay, so they've given us the value for pi. That's here. They've said it's 22 over 7. And they've given us the radius. So what I need to do is I need to put this information in. So the area of the circle equals 22 over 7 multiplied by 7 multiplied by 7. Okay, so this is interesting. This bit here, this is the trick for this question so it doesn't become too complicated. If I have 22 over 7 times by 7, this is like saying 22 divided by 7 times by 7. So essentially this 7 is just reversing this divide by 7. So I can simplify this calculation to get the area of the circle to 22 times 7. Okay, so now I need to do that. I need to work that out. I'm going to use the column method to do this. Okay, so 2 times 7 is 14. That's 41, sorry about that. Oh no. 2 times 7 is 14. So I put a 4 here and carry the 1. 2 times 7 again is 14. So I add the 1 to that, so that makes it 15. 1 here. So 154. So 22 times 7 is 154. So I know the area of the circle is 154 centimetres squared. So if the area of the circle is 154 centimetres squared, the volume equals the area of the circle times height. So I simply have to do 154 multiplied by 10, and that will give me 1,540 centimetres cubed. City and Guilds are pretty mean making you do all of that for 1 mark. I know that when this sort of question appears in calculator papers, sometimes it's worth like 2 or 3 marks on other exam boards. So yeah, that's a bit of a mean one there, but I guess they've got their reasons, and it'll all be relevant in the way that they assess. So I'm not questioning them, I'm just saying it seems to be a lot of work for 1 mark. Right, question 7. What we've got here is we've got 11 over 8 take away 1 over 16. Okay, so this is a fractions question. Now, operations with fractions for adding and taking away can only happen when the fractions have the same denominator. Okay, so what we're going to have to do is we're going to have to convert these fractions so they have the same denominator. Now, I can see that 11 over 8 is actually, I know that 8 just simply doubles to become 16. So if I double 11 over 8, if I times that by 2 as well, I get 22 over 16. Okay, so here I've got 22 over 16, and now I can complete the calculation. So I've got 22 sixteenths, take away 1 16th, and this is going to equal 21 over 16. Okay, now they haven't given me 21 over 16 as any of these solutions because they've given the numbers as mixed numbers. So I need to rethink about this 21 over 16 as 16 over 16 plus 5 over 16. Okay, and this 16 over 16 is equivalent to a whole because when we complete a fraction, it's equal to 1. So this 16 over 16 is going to be equal to 1. Okay, so I'm going to call this 1 5/16, which is option C. Okay, great. Right, let's keep going. Right, here we go. We've got question 9 here, and this says, what is the perimeter of this triangle? Well, the clue to this question is that this is 60 degrees, this is 60 degrees, which means that this is 60 degrees, as all angles in a triangle equal 180. So if this is 60, this is 60, this must be 60. And you might have remember from the question earlier, we talked about regular shapes, okay? So if a shape is regular, it means that all the angles and sides are the same. Well, the thing is that if all the angles are the same, all the sides have to be the same, okay? So it doesn't work the other way around. Well, it does with triangles, but with other shapes it doesn't. But if all the angles are the same size in a triangle, all the lengths have to be the same size. So here, we know that they're all 60. So if we know that this side is 24 millimeters, we know that each of these sides is going to be 24 millimeters. So the perimeter of this triangle will be 24, add 24, add 24. Okay, and that's going to give us 4, 8, 12. Okay, it's 2, 4, 6, 7. Okay, so the perimeter of this triangle will be 72 millimeters. Okay. Let's continue. Right. Question 10. Okay, we're getting into the more wordy questions now. A call centre aims to deal with calls in less than 5 minutes. Calls come in randomly. The table shows data for calls made to the call centre. Work out the probability that the next call will be a customer complaint completed in under 5 minutes. Give your answer here. So, right, customer complaints make up half of all the calls, okay? So half of all of the calls are a customer complaint. No, a quarter of all the calls, sorry, I'm reading the halves here. A quarter of all the calls are customer complaints. That's what this is saying. And then we're saying that half of those complaints are completed in less than 5 minutes. So basically what we're looking at is we're trying to find out half of a quarter, okay? We know that a quarter of the calls are complaints, half of those are completed in less than 5 minutes. So half of a quarter of means times, okay? So we want half of a quarter, half times a quarter. So this is going to be 1 times 1 is 1, 2 times 4 is 8. Because remember, with multiplying fractions, we just do the top times the top and the bottom times the bottom. Okay, so that's already in its simplest form because I can't get a number smaller than 1. So I'm going to put that there. Okay, right, great. Let's continue. Question 11. The government announces that the minimum wage for people over 25 years old will increase from £8.21 to £8.72 an hour. A 26-year-old woman who works 30 hours a week is paid the minimum wage. She thinks that extra money will cover a rent increase of £20 per week. Is the woman correct? Show your calculation. Right, so we need to work out how much more money she's going to be earning an hour, and then we need to work out what that will be if she gets that amount of money for 30 hours a week. Okay, so the first things we're going to need to do is we're going to do £8.72 take away the £8.21. Okay, 2 take away 1 is 1, 7 take away 2 is 5, 8 take away 8 is not. So she's earning 51 pence more an hour. 51p per hour. Okay, so this is her increase. So now we need to times this by 30. Okay, so we're going to do 51 times by 30. Well, timesing by 30 is like doing 51 times 3 times 10. I'm going to split this 51. I'll just do this method for timesing it by 3. 51 times 3. So 3 times 1 is 3. 5 times 3 is 15. Okay, now I've got 153 here. Oh no, is that right? Yeah. So this is going to be 153 pence more an hour, but actually we've got to times that by 10. So it's going to be 1530p. So this is going to be her weekly increase. 1,530p. This is £15.30 an hour. £15.30 a week. So no, she isn't going to... Oh, that's sad. I feel for this woman. Right, this isn't going to cover her rent increase. So we're going to tick no. Okay. And that's fine. So we've proved that she isn't going to be able to cover her rent increase with her pay rise. Okay. Right. Question 12. A driver sees a speed limit for a sign in France. The speed limit is in kilometres per hour. Okay, and it says 130. He is driving 80 miles per hour. He thinks this is below the speed limit. Is he correct? Explain your answer showing your calculation. Right. So, 1 kilometre is 5/8 of a mile. So we've got here 130 kilometres. Okay. So essentially what we're doing is, this is a direct proportion question really. So we've got 1 km equals 5/8 of a mile. Okay. We want 130 kilometres to make the comparison. So we're timesing this by 130. So I've got to times my 5/8 of a mile by 130. Okay, so I'm timesing that by 130. So essentially I want 5/8 multiplied by 130. Okay, so this is like multiplying by 130 over 1. So what we're getting here is we're going to get 5 times 130 all over 8. Okay, I'm going to look to simplify this a little bit before I work it out, because there's no point doing the whole calculation if I can simplify a little bit first. I'm going to treat this as 5 times 13 times 10 all over 8, and then I'm going to simplify this a little bit. So this is I'm going to cancel down here. So I'm going to make this a 4. I'm not going to make that a 4. I'm going to halve both of these. So I'm going to make this a 5 and this a 2. Okay, so I'm now looking at 5 times 13 times 5 all divided by 2. So let's work out that top bit. 5 times 5, well, I think I'll do the 5 times 13 first. 5 times 13 is 65. 65 times by 5, all divided by 2. Oh, this just isn't a nice calculation, I'm afraid, but it is 2 marks. So let's look at it like this. We've got 65 times 5. Okay, 5 times 5 is 25. Okay, 5 times 6 is 30. Add the 2 is 32. Okay, so this is 325 over 2. So there we've got 325 divided by 2. Okay, I'll think about this as 300 plus 200 plus 20 plus 5. Half of 300 is 150. Half of 20 is 10. Half of 5 is 2.5. So this will equal 100. Oh my gosh, I've gone really wrong. I'm really sorry. I've led you all down the garden path somewhere, because I know that this can't be right. This can't be right at all. Oh, I halved these. This should be a 4. Okay, there we go. So half of so this becomes 162.5 over 2. Okay, so now we're looking at 162.5 divided by 2. So I've got to halve all of these components again. Okay, so this is going to become 75. This is going to become 5. And this is going to become 1.25, which equals 81.25. Okay, so, wow, they're in the speed limit. There we go. So this is 81.25 miles. 130 kilometres is 81.25 miles. Okay, and there we go. That's fine. So we've done that. So 80 miles, 130 kilometres an hour is 81.25 miles per hour. So that is fine. They are within the speed limit. So we are all good. Okay, question 13. Let's have a look here at what's going on. So we've got here, a man has a fish tank with the following dimensions. We've got a width of 41, we've got a height of 29, and we've got a measurement here of 24. Okay, they're all in centimetres, so that's fine. He needs to know the approximate volume of the tank. So approximate's nice. That means that we can round these numbers. Okay, so if I round these numbers, I'm going to say that this is 20, this is 40, and this is 30. Okay, so if I've rounded these numbers, we've got here 20, 30, and 40. So what I can now do is the volume of a cuboid is length times width times height. So I'm going to look at 20 times 30 times 40. Okay, so I'm going to do this by doing 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. So that's going to be 24, and then I'm going to add on the 3 zeros. 1, 2, 3. So the volume of this is going to be 24,000 centimetres cubed. And that is the end of section 1. Okay, so let's quickly go back to the start of that, because I just wanted to see how much time were we meant to be allowed for that, and how much time did we take. So we're allowed 25 minutes, and that's pretty much what we've taken actually. We're about 30 minutes into the session, so with my waffling and stuff, I'm sure that was about 25 minutes. Right, let's move over to part 2. Okay, so part 2, we are allowed a calculator for. Okay, so here we go. So I will bring up my calculator. Let's find it. It's an hour and 20 minutes here, so this is a bit about a race against the clock here, because we've got an hour left. So hopefully we will get this all done. Let me get the calculator. Here's my calculator. Let me position it so it can be seen. I always struggle with calculator positioning. Okay, I'm going to leave it off the screen. I'm only going to bring it on when required. So here we go. Let's get started. Okay. Question 1. 0.06 million divided by 6.2 thousand. Okay, fine. Let's just work these out. Okay. So I'm gonna turn these into normal numbers now. So 0.06 million is 0.06 times 1 million. So 1 million is 1 with 6 zeros. Okay. So here we go. So that is 0.06 million is 600,000. No, 60,000. Okay, 6.2 thousand is going to be 6.2 times 1,000. And that equals 6,200. So now what I need to do is I need to do my 60,000 divided by my 6,200. So 60,000 divided by 6,200. And here we go, this equals 9.677, which equals 9.68 to 2 decimal places, because remember, if the number after the decimal place that you're rounding up to is greater than 5 or more, then we round up. Okay, so here we go. So that's first question done, 9.68. Okay. What is 3 over 87 as a decimal correct to 3 decimal places? Okay, so remember that line there means divide. So to do this, we're just doing here 3 divided by 87. Okay, what was it? Here we go, 3 divided by 87. And this equals 0.0344. So 3 divided by 87 equals 0.0344. So to 3 decimal places will mean that this is the last number. Okay, so that 4 is less than 5, so that means we just ignore it. So this answer will be 0.034. Okay, let's move on to question 3. Here we go. Question 3 says the diagram shows the outline of a building. Okay, here we go. Which of the above shows the elevation of the left side of the building? Okay, so this is the left side of the building. Okay, I think, yep, just double check my left and right. This is the left side of the building. So what we've got here is, all we're going to see is this. Okay, because we're going to see the side and we're going to see the roof. So there we go, it's going to be that one there. So it is C. Okay, let's have a look at the next one. Question 4. 1 meter cubed is the same as... okay, right. So to do this, I'm just going to draw a cube. I'm just going to draw a cube. Okay, and this is a meter cubed, but instead of putting meters on it, one second. I'm drawing this and I'm hiding it properly. I'm going to put these measurements in centimeters. So 1 meter equals 100 centimeters. So instead of it being a meter cubed, I'm going to think about it in terms of centimeters. So this is 100 centimeters, this is 100 centimeters, and this is 100 centimeters. Remember, the volume of a cube or cuboid is length times width times height. So I'm now going to do 100 times 100 times 100. Okay, so this is 100. Let me bring back my calculator. 100 times 100 times 100. And so that is 1 and 6 zeros. That is 1,000,000. So it's this one here, 1,000,000 centimeters cubed. Okay. Right, let's have a look at question 5. So here it goes. Question 5. We've got a social club sells 50 pink raffle tickets and 75 yellow raffle tickets. Tickets are drawn randomly. What is the probability that the first ticket drawn will be a pink ticket? Okay, so this is going to be how many pink tickets are there? 50. Out of how many tickets are there in total? Well, there is 75 yellow plus 50 pink. So that will be 50 out of 125. Okay, so there we go. So there is 50 out of 125 tickets that are pink. Oh, they want the probability as a decimal. So I'm going to have to work this out. Remember, it's top divided by bottom. 50 divided by 70. Oh, no, I'm going wrong. 50 divided by 125. And that equals 0.4, which is a lovely decimal. So the probability is 0.4. Okay, right, let's have a look at question 6. So here we go. Oh no, I had calculator problems there. Okay, right, question 6 says, the chart shows finishing times of marathon runners. Okay, let me just move my calculator away. A report states that most of the runners finish in under 4 hours. Is the report correct? Explain your decision. So most of the runners finish in under 4 hours. So that is going to be these runners, and these runners. I think that looks like less than half of the area of that graph. Okay. How many marks is this? This is 1 mark. So I'm going to say, I'm going to say no. I'm going to say that they don't. And the reason for that is because more people finished after 4 hours. We could make a guess. Actually, let's make this a bit more mathsy because they might not be happy with that by itself. So what I'm going to do is, do you see these points here? I'm going to use these as an indicator. Okay. So what I'm going to say is here. So we've got this is about 100. This is about 65. This is about 20. I'd say that's about 25. Okay, and then this one, it looks to me to be about 70. This looks to be about maybe about 48. This looks to be about 25 as well. This looks to be like 10. This looks to be like maybe that's more like 18 actually. Maybe this is more like 10. And this looks like 5. Okay, so we can add these up. So 100 plus 65 plus 25 equals 190. And then on this side we've got 70 plus 48 plus 25 plus 10. Oh, I missed the 18 plus 18. Oh, I'm sorry, I'm adding these together on my calculator. Sorry, 18 plus 5. That equals 176. Oh, you know what? He might have been right then. He might have been correct. Yeah, our math shows that he is right. It's just that the area of this looked like it was more. But no, I think he's probably correct. So is the report correct? Let's go with yes, okay? And that's because, well, it looks like we've got our kind of justification here. It looks like more runners are before the 4-hour mark than after. Okay, right. Okay, question 7. Let's have a look at this one. So it says here, a shop has a sale. There is a 30% off all black tag items. 30% off. Reduced price is £21. On the day this notice appears in the shop. One day this notice appears in a shop. And it says, one day only, black tag, an extra 25% off the marked reduced price. Better than half price. A customer explains that this is misleading because it's not true. Explain your decision. Okay, so let's just make up a price for here and let's apply this offer. Okay, so let's say, okay, I'm going to bring out my calculator. Let's say we've got an item, okay, that costs £100, okay? We've got an item that costs £100. So 30% off this item. So remember, if we want to reduce an item by 30%, we've got 100% and we're taking away the 30%. So that equals 70%. So if we want to reduce an item by 30%, we're looking for 70% of the cost. So we need to turn the 70% into a decimal. So 70 divided by 100 equals 0.7. Now anything that I multiply by 0.7 is going to be reduced by 30%. So 100 times 0.7 equals £70. So 30% off means £70. Now they're reducing this price by 25%. So the same thing again. So 1 second, let me just show that there. So same thing again as this. We're going to do 100%. We're going to have to take 70 as our new 100%. 100% take away 25% equals 75%. So if you want to reduce something by 25%, you're looking for 75%. So 75% divided by 100 equals 0.75. So if you want to reduce the cost of something by 25%, you multiply it by 0.75. So let's do 70 times 0.75. Okay, 70, I'll bring my calculator back on. So here we go. 70 times 0.75 equals £52.50. Okay, and this is less than 50%. This is actually worse. So if the starting price was £100, after these two reductions, we end up with £52.50, which is more than 50%. Well, which is more than half of the cost. So it is not better than half price. Decision. Is the customer correct? Explain your decision. Okay, so here we go. The customer is correct. Explain your supporting calculations. If an item cost £100, the first reduction would take it to £70. Then the second would take it to £52.50, which which is more than half its price. Okay, there we go. Let's have a look at the next question. Right, here we've got question 8, and it says here, a craftsman, oh, let me remove my calculator. A craftsman uses resin to make a paperweight. He makes a paperweight from 2 parts, a hemisphere and a cylinder. He uses this plan. Okay. How much resin does he need for both parts? Show all of your working out. Okay, so we have got here the formula for the volume of a hemisphere, okay, which is going to be useful for helping us find out the volume of this hemisphere. We are required to know how to calculate the volume of the cylinder. Okay, so it doesn't matter which bit we do first. Let's do the volume of a cylinder first. So remember, the volume of a cylinder, we looked at it just before, see if you can remember, have a quick think, is going to be volume equals area of circle times height. Okay, so again though, we need to actually know the formula for the area of a circle. So area of a circle equals pi times radius squared. Okay, now in this question they haven't given us the radius, but they have given us the diameter. So if we remember about circles, if I've got a circle here, the diameter goes all the way across, and then the radius is half of that. Okay, so if this measurement all the way across is 6, then the half measurement is going to be 3. So we've got a radius here of 3. Okay, we've got a radius of 3 there. So let me continue with that question. So pi, they've told us, is 3.14. So the area of the circle is going to be 3.14 multiplied by 3 multiplied by 3, and then multiplied by the height, which is 5. Oh no, well, the volume will be then to multiply by the height, which is 5. I might as well just do that all in one go, actually. Volume, and then it's going to be times the 5. So remember, this bit has given us the area of the circle, and then this other bit here has extended that, so we're getting the volume. So I'm going to bring out my calculator for this. So here we go, I'll just put that up here. So we have got 3.14 times 3 times 3 times 5. Okay, so the volume of this bit is going to be 141 equals 141.3, and that's centimetres cubed. Okay, and now we can do, we've got all the information we need here for the hemisphere. So I'm going to write this out though. So it's the volume of the hemisphere equals 2 over 3, and then what was it, pi r cubed. Okay, so 2 over 3 pi r cubed. Okay, so what that's going to mean here, let me just move my calculator over to here. 2 over 3 means 2 divided by 3. And then remember, when we see things like pi and letters next to each other, that means we're multiplying them. So pi is 3.14. So 2 divided by 3, I'll put brackets around this, times 3.14 times the radius, which was 3. So times 3 times 3 times 3. Okay, so when I do that in my calculator, I'm going to do 2 divided by 3 first. I'm just going to press equals there, so I've got that as the answer, so I'm not messing anything up with everything else. And now I'm just going to type in the rest of the timesing. So times 3.14, and then times 3 times 3 times 3, because cubed means you multiply it by itself 3 times. Okay, right, and here we go. So this is equal to 56.52. So then if I add this on to this, Okay, so I'm going to add on the 14141.3. Okay, press equals, and that's going to give me 197.82. Okay, wonderful. There we go. And that was 4 marks. Okay, so that's nice. Right, let's move on to the next question. Right, question 9. I don't know if I need my calculator for this. Let's have a look. But here we go. We've got a gardener wants to build a greenhouse in the top right-hand corner of her garden. Okay, 2 meters by 2.5 meters. Here is a sketch plan of her garden. Ah, this is nice. So here we go. 5.5 meters, 4 meters, 5.5 meters, 2.5 meters. She will leave a 50 centimeter space between the greenhouse and the edge of the garden. She wants a scaled plan of the garden showing the position of the greenhouse. Draw a scale plan. Okay, so let's have a think about this. And let's get started. So let me just scroll up here. When thinking about these, we've got to think about really what we want to use as our scale. Okay. I'm going to be inclined with this one just to use every small square is 10 centimeters. Now, the reason for that is it makes it easy because it means that a length from here to here is going to be 50 centimeters. Okay, so I think that's what's just going to work nicest for this. So I'm going to say that's 50 centimeters. Okay, let me rub that. Well, actually, I'm going to leave that there just to show that. So let me start drawing the sketch. So this would be 1 meter. This would be 2 meters, 3 meters, 4 meters, 5 meters, and then 5.5 meters there. Now I'll go down here. So that'll be 1 meter. That'll be 2 meters. So this is 5.5 meters. I'll just write that. That's 1 meter. That's 2 meters. That's 3 meters. 4 meters. Okay, I think that was 4 meters that we wanted here. Yep. So I'm going to put 4 meters here. Now what I'm going to do is I've got 5.5 meters going down there. So remember, each one of these is 50. So that we've got 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 5 meters, 50. Okay, so that's another 5.5 meters there. And then along here, I've got 2.5 meters. That's 50, and that's 1 meter, 2 meters. And then I can see from the sketch that I just joined these bits up. Okay, so this is the sketch of the garden drawn to scale. So let's now have a look at where we're going to put this greenhouse. Okay, she will leave a 50 centimeter space between the greenhouse and the edge of the garden. She wants a scale plan of the garden showing the position of the greenhouse. Okay, so we can put this where we want. Okay, it's got to be 2 meters by 2.5 meters. Okay, so let's just, but it's also got to be 50 centimeters from the edge. So I'm actually going to put it here because there's loads of space. If this is 4 meters and this is 5.5 meters, it can definitely go over here. So I'm going to do 2 meters this way, 1, 2, and I'm going to do 2.5 meters this way. So that's 1 meter, 2 meters, and half meters. So here we go. I can draw all of this together like this. And there we go. We've got our greenhouse successfully in the garden, 50 centimeters away from the edge. You could have, there's actually multiple places. I could have put this bang in the middle, I guess. Though I think she does want the 50 centimeter space. So I think it was important to put it there. Right. Next question. There is spare graph paper on page 23. Right. Question 10. A student wants to raise £100 for charity. He will sell hot dogs at a disco. He will make 150 hot dogs. He buys the ingredients at the supermarket. Hot dog sausages, tin of 8 is 50p. Hot dog buns, pack of 6 is 90p. If he sells all the hot dogs, what is the minimum price he must charge to make a profit of £100? Okay, so first things first, we need to work out how much it costs to make 150 hot dogs. So first of all, we need to know how many tins we need, and then we need to know how many buns we need. So if I know that there's 8 sausages per tin, 8 per tin. Okay, so 1 tin is 8 sausages. I need to work out how many tins is going to be 150 sausages. So I need to work out what do I times 8 by to get to 150. So remember, if I'm working this out, what I can do is a reverse calculation here. So I'm going to do 150 divided by 8, and that will tell me the number of tins I need. Remember, this is a calculator paper, so I can always use my calculator here. So 150 divided by 8 equals 18.75. Well, we need more than less, so we're going to have to go for 19 tins. So we want 19 tins of hot dogs. Okay, now with the buns, we've got the same thing. The buns come in packs of 6. So we've got how many packs of 6 do we need to get 150 buns? So again, we can reverse this calculation. 150 divided by 6 and find out what that is. So here we go, 150. Where's my calculator gone? Oh no, I've closed it. Here we go, 150 divided by 6 equals 25. So we want 25 packs of the buns. So 25 packs. Right, now let's work out how much this costs. So I'm going to convert these monies into pounds because this is in pounds and everything else is in pounds, and it's going to help us out. So what I'm going to do is 50p is equal to 0.5 pounds because I've divided it by 100, and 90p is equal to 0.9 pounds. Okay, so when we're talking about pounds, that's this. So now if I've got here, let me put this down here. If I've got 19 tins, I want 19 times the cost per tin, which is 0.5. So this is going to be £9.50 for the sausages. And then I'm going to do 25 packs of the 0.9. So 25, that's a 5. 25 times the 0.9. So that's going to be £22.50. Okay, so £22.50 for the buns, £9.50 for the hot dogs. So the total cost that she's spending is going to be £9.50 plus the £22.50. So if I add those together, let's see what that gives us. Add £9.50. And so that equals £32. So we've spent £32 on the hot dogs and the buns. Okay, right, so if her spend was £32.50 and she wants to make £100, we've got to add £100 to this, and we'll see that she needs to make £132.50. Okay, so that's what she's going to need to, that's how much money she needs to make. Okay, so she needs to make £132.50. Okay, so what we now need to do is we now need to split that cost between all of the 15 hot dogs. Okay, so let me just make some space over here. So what we need to do is we need to split that between the 15 hot dogs. So we need to do £132.50 divided by the 150 to find out the cost of each hot dog. Okay, so 132.50 divided by 150 will equal 0.883. Okay, we're going to have to round this up, because if we don't round it up, she won't make her £100. We wouldn't normally round 0.3 up, but in this case, we're going to have to. So the minimum price per hot dog for her to make her £100 is going to be 0.89. So 89 pence. And yeah, that's that. Okay, let's see how we're getting on. Right, question 11. Okay, so here we go. We've got here that a supermarket buyer compares large eggs from two suppliers. She wants to buy the largest eggs. Okay, the table shows the masses of the sample of large eggs from supplier A. Okay, a similar sample is taken from supplier B, which gives a mean value of 66.5 grams. Which supplier should you use? Explain your decision. Right, okay, so this is a mean from a grouped frequency table. So we always, with these questions, remember that the mean equals everything added divided by number of things. So in this case, it's basically everything added is going to be the weight of all of the eggs added together, and then the number of things is going to be divided by the number of eggs. Okay, so let's first of all work out how many eggs there are that we've got to divide by. Okay, so I'm going to just add these all up to get the total number of eggs that supplier has given in their sample. So we've got 22, add 27, add 26, add 15, add 10. Okay, so that's nice and easy. It's a sample of 100 eggs. Right, now we need to work out what the total weight of all of these 100 eggs is. Unfortunately, they've given us a grouped interval, so we don't actually know the exact weight of these eggs. So we've got to estimate the weights of these eggs. And the way that we estimate the weights of these eggs is, let me just move this down here. The way that we estimate the weights of these eggs is by adding these two bits together and dividing it by 2. Okay, so for this first one, we're going to estimate the weight of the eggs for the first group are going to be 63 plus 65 equals 128. And then we're going to divide that by 2, which is 64. And actually, that's quite obvious because that is the number that's directly in the middle. So we can actually see that with this pattern here. So 63, 64, 65. So we're going to say they're 64, 65, 66, 67. We'll say that these are 66. We'll say that these are 68. We'll say that these are 60. These are 70. And that these are 72. Okay. Now, here, if we've got here that there's 22 eggs that are the 64, we've then got to times this by 64, and that will give us what we're going to say those 22 eggs weigh. So 64 times 22 equals, so I'm going to write this down here. So 22 times 64 equals 1408. So we're saying those 22 eggs weigh 1,408 grams. Then we've got 27 times 66. Then we've got 26 times 68. Then we'll have, what are we going to have next? We'll have 15 times 70. And we'll have 10 times 71. Okay, times 72 even. Well, I know that that's 720. Okay, let's work out these other three. So here we go, 27 times 66 is 1782. 26 times 68 is 1768. And then 15 times 70 is equal to 1050. Okay, then if we add all of these numbers together, we're going to get the total weights of all of the eggs added together. So let's add these together. So we've got 1408 add 1782 add 1768 add 1050 add 720, and this equals 6,728 grams. Okay, so that's what all of the eggs all together weigh, 6,728. Okay, now we need to divide that by 100 to find the mean. Okay, because what we're doing is we're redistributing all of their weight, their collective weight, equally. So that's what the mean is. It's everything added together divided by the number of things. So we're going to distribute all of their weight equally. So if we divide this by 100, this equals 67.28. So we can compare this now to this one. So these eggs are heavier than supplier B's eggs, which means that supplier A's eggs are presumably larger. Okay, right, there we go. We'll tick that off and go to the next question. Question 12. Hopefully we're getting towards the end now. Okay. A man has £5,000. He will put his money into a savings account. He wants to save it for 1 year. Bank A pays 2% compound interest. It adds every 6 months. Okay, so every 6 months is going to increase the amount of money in the bank by 2%. Bank B pays annual interest rate of 3.15%. Which bank should the man choose? Well, let's try it out. So remember, if we're increasing something by 2%, we do 100%, add 2%, which equals 102%. We divide this by 100, which equals 1.02. Now, anything we multiply by 1.02 will be increased by 2%. So what I can do is I can do 5,000 times 1.02 times 1.02, because this is going to happen twice in the year. Okay, so let me just move my calculator over a little bit. So here we go. We've got 5,000 times 1.02 times 1.02. Okay, and this equals £5,202. So that's what he'll get from Bank A. Now, Bank B, remember, same principle, 100% plus 3.15 equals 103.15. Divide it by 100 equals 1.0315. Now, anything we multiply by 1.0315 will be increased by 3.15%. But this is only going to happen once, so this time, so let's try 5,000 times 1.0315, and let's see what this gives us. So 5,000, oh, that's an 8. 5,000 times 1.0315. Okay, and that equals 5157.5. Okay, there we go. And we can see from this that Bank A is better. So we can give Bank A a tick. Right, question 13. A magazine article has this headline: Garden birds in decline. Fewer birds seen in our gardens. Okay, let me just move the calculator. Okay. The graph shows some data about the two types of garden bird. Okay. So here we go. We've got chaffinch and sparrow. Is the magazine headline correct? Show subtle calculations of percentage changes in the last 10 years on the graph to support your answer. Make 2 comments. Okay, so, right. Make subtle calculations of percentage change. Comment 1. So, I think comment 1, we can say, from here to here, we can see that there has been no change in the number of chaffinches. Okay? Comment 1. The number of chaffinches is the same as it was 9 years ago. Okay. Now we need to look at the sparrow. Oh no! I got them wrong. The number of sparrows. The number of sparrows is the same as it was 9 years ago. Okay. Right, now let's do the percentage change for the chaffinches. So there was 4, 2. Okay. So let's say chaffinches have decreased from 4 to 2. Okay. So percentage change is how much it's changed out of how much it started. Okay. So that is a so we've got change divided by original times 100. So this is percentage change. So we've got it decreased by 2, and that was out of 4. And so we times that by 100. 2 divided by 4 times 100 will give us the percentage change. 2 divided by 4 times 100. And that's 50. Chaffinches have seen a 50% decrease. Chaffinches have seen a 50% decrease. Okay, right. Question 14. 5 marks for question 14. Okay, so let's have a look. It's nice and long. Okay, a team manager wants to pick 4 people for a bowling competition. She decides to pick players with consistently good average, medium performances. She picks the following 3 people: Archie, Baz, and Kathy. Okay, so their median on the last 8 matches is given here, and their range is given here. She needs 1 more player to make up the team. She looks at the scores of 2 more players, Dave and Elaine. Make suitable calculations for Dave and Elaine and decide which player best fits the requirements. Explain your decision using your figures. So, we are looking at comparing median and range. Okay, so the median is the middle value when they're all put in order, and the range is, I'll put this over here, the range is the highest, take away the smallest. Okay, so let's do the medians first. So median, and then we'll compare the range, and then we've got Dave, Elaine. Okay, so let's put Dave's scores in order. So Dave's lowest score is 48. Then we've got a 67. Then we have a 78. Then we have a 86. We've got an 86. We've got an 86. Then we've got a 96. Then we've got a 98. We've got 101 and 102. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 scores, which means that there's 2 numbers in the middle. So we've got 2 values in the middle here, because we can see they've both got 3 either side. So Dave's median is between 86 and 96. So we have to find out the average of those two. So we do 86 add 96, and then we divide that by 2. So let's do that on the calculator. 86 add 96 equals this. And then if we divide that by 2, that's going to give us 91. Okay, so we've got here the median for Dave is 91. So I'm going to put, we've got Dave's median is 91. We might as well do his range actually while we're here as well. So the range is his largest, take away the smallest. So Dave's range goes from 108 to 48. No, 102. 102, take away 48. And that's 54. Okay, now let's look at Elaine. Okay, so I'll write down Elaine's scores in order here. So we've got 79. We've got 84. We've got 87. We've got another 87. We've got a 93. We've got a 97, a 98, and a 101. Okay, so we can see that it's again 8 pieces. So the middle is going to be between 87 and 93. So we need to do 87 add 93 and then divide that by 2. So I can do that on the calculator. 87 add 93 equals this. Divide it by 2. That's 90. So Elaine has a lower median, but let's now work out her range. So her range goes from 101 and then it goes down to 79. And this equals 22. Okay, so I think personally she should pick Elaine because her results are more consistent. And that means that you can rely on Elaine better. Even though her average is 1 below Dave, I think genuinely she performs better. Although, the thing is, we could say, has Dave made a lot of improvement? Maybe that's why his results were bad and now they're good. It's difficult to say, but she said here she wants players with a consistently good average. So the fact that she wants a consistently good average means that we want Elaine. If the results were wildly different, if their medians were wildly different, we'd probably pick Dave. But because she wants that consistently good average, we're going to pick Elaine. Right. Oh, another question. These papers are so long. Right. A fisherman sets off from Dunsey in a boat. His boat will travel at an average speed of 5 kilometers per hour. He has this map so he can avoid the rocks. Okay, right. He needs to meet up with a ship at L34 at 5 p.m. L34 at 5 p.m. He needs to know what time he must leave Guernsey. Show you're working out. Oh my gosh. Right. Where is Guernsey? Okay, here. A boat will travel at an average speed of 5 kilometers an hour. He has this map so he can avoid the rocks. Okay. He needs to meet up with a ship at 5 p.m. At what time must he leave Dunsey? Okay, so I'm guessing... Ah, okay, he needs to avoid the rocks, so he needs to go like this. I'm going to say he can go close to the rocks. This is still avoiding the rocks. Okay, so we know that one of these squares is a centimetre. So let's work out how far this is. This is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. So our journey is 13 centimetres, okay? And our scale is 1 to 2,500. So 1 to 2,500. And that means 1 centimetre to 2,500 centimetres. Okay? So in our case, that means 13 centimetres. Okay? And let's work out how far that is. So 13 times 25000. And this equals 325,123 centimetres. Right. The speed that we've been given was 5 kilometres per hour. Okay, so we need to get our centimetres into kilometres. Okay, so let's work out what we can do with that. So 135000 cm. Well, if we divide it by 10, we can turn it into metres. Is 135000 metres. Now, if we divide this by 1,000, we can get it into kilometres. So this is 13.5 kilometres. Okay, right. So 13.5 kilometres. So if we do 5 kilometres in 1 hour, we need to know how far we do 13.5 km. Okay, so we need to, here, work out how many lots of 5 is 13.5. So 5 times what equals 13.5. So the way that we can do that is by doing 13.5 divided by 5. And we can see here we've got 13.5 divided by 5. And this equals 2.7. Okay, so it's 2.7 hours. Okay, 2.7 hours is a bit of a nonsense time, really. So let's turn that into hours and minutes. So we know it's 2 hours plus 0.7 of an hour. Okay, to find out what 0.7 of an hour is, we do 0.7 times 60, and that's going to tell us that in minutes. So 0.7 hours equals 42 minutes. Okay, so his journey is going to take 2 hours, 42 minutes. Okay, now let's have a look back at the top of the question to see. He needs to meet up with a ship at 5 p.m. He needs to know what time he must leave Dunsey. Okay, so he needs to leave 2 hours and 42 minutes before 5 p.m. So if we're at 5 p.m, if we take 2 hours off that, we're at 3. And then if we take 42 minutes off that, okay, we're working back from 60. So that's going to be 2 hours and 18 minutes. So he needs to leave Dunsey at 2:18, which is going to be 14:18. Okay. Right, there we go. Some graph paper. And that's the end. Oh, goodness me. That felt like a long paper. Well done if you have stuck with me to the end. Well done if you've watched all of this. Thank you so much for joining me. And yeah, I will hopefully see you next week in another past paper walkthrough. Or if you're somebody that still needs a lot more work on some of the foundational skills, remember I've got my Back to Basics course at the moment. And other things that you can be doing if you want to take this course at your own pace is remember there is the tutorials here in the resources section where I've broken down every topic into manageable chunks. So you can click on any of these and say if you wanted to improve your decimals, for example, how to write decimals in size order, click here and there's going to be a video. There's going to be a, oh dear, where have we gone? Okay, right. Well, I've lost it. here we go. There's going to be a video for you here that you can watch, and there will be some practice questions for you as well. I mean, I'm actually really just pleased that we managed to do all of that in the hour and a half. So, yeah, anyway, lovely to see you all. Thank you so much for joining in, and I will catch you in a